Let's go over two of our methods for solving systems of equations. So a system of equations is when we have two equations. Well, a system can actually mean any number of equations, but specific to the problem I have here on the screen, we've got two equations and we have two unknown values. So when we're trying to solve this system, a system meaning we have multiple equations in conjunction, and we want to know what ordered pairs satisfy both of those equations or satisfy all the equations in the system. What we have are a couple of options. So we could graph, right? Graphing is always an option, but graphing has its limitations. It is one, takes a little bit of time to graph accurately equations, and two, it can sometimes be difficult to pinpoint where our two graphs intersect. And so instead of going down the road of graphing, I want to focus on our other two methods. So two methods that we have that I want to focus on in this video are what are called substitution. So one method, substitution, and the other method called elimination or addition method. And so those are the two methods that we'll focus on here. So what substitution does is we take one of the equations and we isolate one of the variables, and then we substitute it or plug it back into the other equation. So let's look at that one first. So let's look at the substitution method, and we'll go through both of these methods here. So for our first I'll actually do the same example in both ways. So let's do the substitution method first. So the substitution method, what we're going to do is we're going to isolate one variable in one equation and substitute into the other equation. So that's what we're going to do. So in our system, I'm just going to write our system down here again, pause the video and write the system down here again. Okay, so here's our system. So if we have this system and we want to use the substitution method, we can pick either of these two. I'm going to go ahead and go with the first equation. And I noticed what you want to do is you want to pick the variable. You have four choices: the x from the first, the y from the first, the x from the second, or the y from the second equation. You just want to pick the one that's easiest. In this case, I see that the y's in either equation are going to be pretty easy to isolate. I'm going to just pick the y from this equation. So I'm going to take that y and I'm going to isolate it. I'm going to do that, and I'm going to kind of, in my head, I'm subtracting 7x from both sides of this equation. So I end up with y equals 10 minus 7x, and that's in my first equation. Now I'm going to take that, because now I know that y is equal to 10 minus 7x, and I'm going to plug that into the second equation, so into equation number 2. So this was still equation number 1. I was just isolating. And now I'm going to take that and I'm going to plug it into equation number 2. So equation number 2 was 3x plus y, this is y, equals 4. But I'm plugging this expression in. I'm substituting for y. So I'm substituting in 10 minus 7x. Now, it was just y right here. There was no constant in front. There was no constant in front here. There was just a 1 right there. Put like a little question mark there, but there's really just a 1 right there. So that's why there's only a 1 here. But anything, like if there had been a 5 right here, then I would have to make sure I distribute it throughout. Okay. Now, all I have to do is solve this resulting equation. So now I'm going to solve this equation. So now we're just going to solve for x. And in this case, we're going to get 3x plus 10 minus 7x equals 4. I'm just dropping the parentheses. Now I'm going to combine like terms. I got 3x and negative 7x. That makes for a negative 4x plus 10 equals 4. I'm going to subtract 10. And I have negative 4x equals negative 6. And then I'm going to divide by a negative 4, just being careful throughout to track my signs. -6 over a -4 becomes a positive, and those both reduce by 2, so a positive 3/2. Now, remember, when we solve a system, we are looking for the ordered pair or ordered pairs that satisfy the equation. So right now, for my solution, I have half of my solution because I know the x value. The solution is going to be an ordered pair that satisfies both of these equations, meaning the ordered pair, if we were to actually graph two lines, if they intersect at a single point, it has an ordered pair as its name. The name of the intersection, mathematically is an ordered pair. So we have 1 point. So right now we figured out what the x value is, but we still have to find the y value. So now we're going to take that and we're going to plug it back in. It actually doesn't matter if we plug it into the first or the second equation, but we're going to plug into 1 or 2 to find y. Now, I'm going to just go ahead and plug into the one I have highlighted right here. I'm going to plug right into there. I know that y is equal to 10 minus 7 times x, so 7 times 3/2. And so y is equal to 10 minus 3/3, 10 minus 21 halves, and 10 is 20 over 2 minus 21 over 2. And so y has got to be -1 over, just doing some common denominators there. So y has to be -1/2. So I can go back here and say y has to be -1/2. And that is my answer. So my solution is the ordered pair 3/2 and -1/2. So that is solving this system of equations using the substitution method. Now, I have another method called the elimination or addition method. Depends on what book you're looking at or what instructor is talking about it. I always reference it as both, either the elimination or the addition method. And that has to do with the process because we're actually going to eliminate a variable by using addition of equations. So the process is sort of in those two words, elimination and addition. So let's go ahead and let's do the same problem. We'll get to the same answer, and you don't have to do these problems in both ways. I just want to show it on this video, the two options. And then when you come across an equation or a system of equations, you pick which method you want to use. So we did the substitution method. Now let's do elimination. So elimination or addition method . What this does is we use multiplication to create opposite multiplication by constants to create what we call opposite coefficients. Talk about that in the context of the problem here in just a second. To create opposite coefficients I'm going to move our equations down a little bit, our system, on one of the variables. Then add the equations to eliminate a variable. Okay, so that's the generalization of what the elimination and the addition method does. We're going to use multiplication by constants. That's going to help us create what we call opposite coefficients. Opposites are numbers that are equal equal in magnitude, but opposite in sign. So like 5 and -5, or -7 and +7. Those are opposites. And we want to create coefficients on the variables so that when we add the two equations, they will eliminate. So let's see, my numbers changed here, but here's my equation 1, here's my equation 2. So if I'm going to do this process here, what I'm going to do is I'm going to pick, we could either pick x's or we could pick y's, and it doesn't matter which ones we use. I noticed that the y's are pretty easy. I could create opposite coefficients by multiplying this whole equation by -1. So if I take this whole entire equation and I multiply by -1, what will happen is it will become -7x, -y, and -10. I have to carry it throughout the entire thing. Notice here I wrote the parentheses all the way around. I have to carry that -1 throughout the entire. When I multiply the equation, I have to make sure I multiply both sides of the equation by that -1. So this is times -1. So I'm taking equation 1 and I'm multiplying by -1. And then I'm not actually going to do anything to equation 2 because it already has a +1 on the y. So I'm just going to carry 3x positive y equals 4. Okay, so notice what I've done here is I've created opposite coefficients, a -1 and a +1. Just a quick side note, I'm not going to do it this way, but we could have done it on the x's as well. So on a side note, what I could have done is I could have multiplied the first equation. Let's just write this really quick. I could have taken 7x plus y equals 10, and I could have multiplied by a -3. So I could have taken the entire equation on top, multiplied by a -3. That would have created a -21x minus 3y equals -30. And then on the bottom, where we had 3x plus y equals 4, I could have multiplied that whole equation by a +7. So I could have multiplied by a +7, this whole equation by a +7. That would have given me a +21x plus 7y equals 28. Okay? I just want to show that we could have done that. That would have created opposite coefficients on the x's. So notice I have -21 and +21. Okay? So I could have done that. I chose to work with the smaller number, right? And it was a little less work. Notice what I did on the top. It was a little less work. I just multiplied by -1. But you can choose to work with either the x's or the y's when you're creating opposite coefficients. And again, just efficiency, right? You want to do what's going to be the fastest. So what I chose here on the top, it was a little bit faster, okay? Because I only had to multiply one of the equations. So I'm going to go ahead, I'm going to erase that. Second line, our work would have been the same, or our work would have been a little different, our answers would have been the same. So I'm going to delete that. Okay, and let's just come back to what we were doing before. So here we're going to take, now we've created the opposite coefficients, so check, we got that done. Now what we're going to do is we're going to do the addition of these two equations. So now notice I'm actually, that plus right there, I'm going to add the two equations. When I do that, -7x, and you want to make sure they're lined up in order to do this. You got to have your x's, then your y's, your equal sign, and then your constant. So make sure if they didn't come that way, our equations happen to come that way. But if they did not come that way, you want to make sure that you write them in ax plus by equals c form in order to use the elimination / addition method. So now we're adding, so now we're getting into that addition part. -7x plus 3x is going to give me a -4x. Notice what happens when you have -y plus y, those cancel, and then we get equals -10 plus 4 is a -6. And now all I have to do is solve, so divide by -4, and I find that x is equal to a +3/2. So for my solution again, we remember that our solution is going to be an ordered pair, like we talked about earlier in the video. And right now I have half of the solution. I have the x value. So I still need to find the y value. So now I'm just going to substitute that back in. Okay, it's called back substituting basically. Back substitute into either equation to find y. So I'm going to take that and I'm going to plug it back into either of the two equations. I'm just going to work with equation 1. So equation 1 says 7 times 3/2 plus y equals 10. So 21/2 plus y equals 10. Okay, so notice I just plugged that into the first equation. And then subtract 21/2. Subtract 21/2, but that's 10/1, so let's go ahead and make a common denominator there, so y is going to be 20 over 2 minus 21 over 2, so y has to be negative 1/2. And so my answer is 3/2 and negative 1/2. And there's our answer. And so either method works here. Let's get them both on the screen. Either one of these two methods work to solve this system of equations. You just want to pick which one, when you come across a system, you want to know both of these methods and then pick the one that makes the most sense. And in this case, I think either method, they were both about the same amount of work here. So both methods are efficient in this particular example. But sometimes you come across something where, one of your variables is already isolated. Your x or your y is already isolated. And in that case, then maybe substitution is a little bit faster, easier. And it just depends. Sometimes it's not easy to isolate one of the variables or gives you lots of fractions to work with. In that case, maybe elimination or addition would be easier than substitution.